Hello, hello. We are back live again here at DevHub Live. Less than 24 hours, actually a little more than 24 hours ago, that we are back with an awesome bonus workshop. I hope you saw the news, but in case you did not see the news, recently, or just yesterday, Shade Agents was announced. And Shade Agents are autonomous agents that we're going to talk all about today. I am super excited for my guest. This is Matt Lockyer from Proximity. And I have had Matt on all of my different shows over the years now, multiple times. He's probably the guest I've had on the most. So I am excited to one more time, and probably many more times in the future, have Matt here to kind of walk us through Shade Agents. Matt, thanks for joining us. Oh, you're muted, Matt. Okay, no problem.
Great to be here. Sorry.
Yeah.
Just tweeting it out, making sure everybody jumps on the live stream. Yeah.
Appreciate it.
How's it going,
Yeah.
Joe?
So I'm super excited to talk about this one because this is actually something I don't know much about it. So I am also coming in just like the rest of the audience, kind of coming in cold. So I'm excited to hear what
you didn't do
it's all
the
about.
homework?
No, I didn't do homework. No, I have some questions, but yeah, let's start high level before we jump into any code or anything like that. What are Shade Agents?
Okay, so just at a very high level, we've heard a lot of stuff: AI, agents, crypto, trusted execution environments, otherwise known as TEEs, or some people say TEEs.
Yeah.
A lot of these technologies are floating around, and Shade Agents, simply put, are basically, we want some worker code. We want some code that can basically that can tweet. We want some code that can talk to Web 2 APIs, maybe LLMs, that are external to the code that's running. And ideally, we want to know that code is doing what it says it's doing. And also, in some instances, we want to know that code is running confidentially.
Yep.
So how do we do that, right? Well, we typically put that code inside a trusted execution environment. So in the Shade Agent stack, we call that a worker agent. It's running inside a T. But now the question comes, how do you manage keys? How do you manage user funds? How do you manage the protocol funds? How do you manage things like price feeds for things that are happening in the protocol? How do you get the code that's inside the T to be verified by the protocol itself? So we have a smart contract that can basically take what's called the attestation of the T, which proves that it's running the code that it's running and proves that it's running in a trusted execution environment. We have a smart contract that can verify that. And then we have various design patterns that can basically block off methods of the smart contract and restrict access to them only if they're coming from those particular worker agents. And then if you sprinkle a little near chain signatures and chain abstraction on top of that, we get decentralized key management on top of that. So now we can manage users' deposits. We can manage funds. We can basically custody crypto assets. So these agents can basically serve as non-custodial agents over, crypto assets, and they can actually do stuff. So if you're coming at this from like the AI meme space, and thinking like, oh, here's some AI agent that was launched with a token. You can think of Shade Agents as being able to launch an AI agent that is a token.
Okay.
Is a token, right? So the agent and the contract are so tightly coupled that the agent fully embodies what it means to be on chain, what it means to be a token, right? So that's what's really exciting here, and that's what we're really excited about.
Yeah. No, it sounds exciting. And so is the attestation part the piece that probably, because like in my mind, I hear like autonomous agents, and I use a lot of AI in my workflows now, and it's not perfect by any means. So is the attestation part the piece where I can feel more comfortable that my agent is just not going rogue as well? Is that where I know what actually this agent is doing from time to time?
That's exactly it. Yeah.
Yeah.
So when you run a worker agent in the Shade Agent stack in a T, you basically get this remote attestation that says it's inside the T, but you also get one other critical piece of information. You get actually the code hash of the Docker image that was deployed.
Okay.
So basically what we're doing here is we're taking our code, like our arbitrary agent code, we're Dockerizing it. Then we get this Docker image hash. And when we run it inside a T, we can extract not just the remote attestation, which is part of the whole T, secure enclave, blah, blah,
Yeah.
blah kind of stuff. Not only can we verify that remote attestation, but we also get along with that the code hash of the code that's running. So we can go over, we can point at that Docker image and we can say, hey, same hash,
Yep.
and we can make sure that these agents are, I think what you're kind of asking is like, can we make unruggable agents?
Yeah.
And
Yeah. Yeah. Yeah.
the answer is yes,
Yeah. Yeah.
and that's another very exciting part about it. So yeah, great
Very
question.
cool.
And we can make these unruggable agents. And then once we connect them to the smart contract, if that agent is in charge of a token, minting tokens, launching a tokens, managing something, some ecosystem or a DAO or a price oracle or whatever,
Yep.
that agent is that thing on chain.
Got it. Interesting. Cool. Where do you want to begin with all of this?
Well, what I'm going to show you is we've put together basically a template of the Shade Agent stack. So I'm going to go ahead and I'm going to kind of bumble my way through a deployment of it. It's not that long or complicated, but I'll just talk about a little bit of the moving parts. And then what we can do is we can focus in on the key parts of the code in the worker agent, and then the corresponding parts in the smart contract that give it that tight coupling that I've been talking about.
Nice.
So you want to go ahead and do that?
Yeah, let's do that.
Okay, cool. I'll just share the window that I'm in. Okay. And let me know if I got to zoom in or do anything like that, Joe. Just
looking good. Yeah.
You're good. Okay, looking good for now. Yeah. So the one thing I want to draw everybody to is github.com/near-defi/shade-agent-template. So you'll find this in the Near DeFi organization, github.com near DeFi, but it's basically the Shade Agent template. And what this template has is it has those two components I'm talking about. It is, in fact, a Next.js app that gets deployed onto Fala Cloud. We'll talk about them in just a sec when we deploy it. But it also has a Near smart contract. So it has both components there. I'm going to go ahead and just, I'm going to go to the Docker Compose here. This is some YAML here to basically just deploy one. So I've already got one here. I'm just going to destroy it. And I'll show you how to do this. So Fala Cloud, let me just give a little kind of primer on that. Fala Cloud is basically like a cloud deployment service for running Ts. So we're running trusted execution environments. And what they're going to do is they're going to take my Docker Compose YAML here, and they're going to deploy an instance. So I'll just call this, I'll just call it Shady. So I'll paste that in. And you can see right here, it's pulling this Docker image, and there's a SHA-256 hash on that Docker image. And it's not a very complicated worker agent. It's just a template for talking to the smart contract, registering, getting that remote attestation and that code hash, which is the hash we're looking at right now. And I'll show you what that looks like in a sec. We'll walk through the UI for this template, which is basically just a way to kind of walk through setting up this agent. And we'll just let it boot up. Give me 1 sec, Joe. I'm just going to stop the sharing for just 1 sec. I'm gonna open up my Near wallet because I do have to fund the agent, but I just don't want anything to fly up because I didn't bring it up ahead of time.
Yeah, no problem.
I want to make sure I'm just on testnet here with my Near wallet.
Yeah, for sure.
Just 1 sec.
one of the things that definitely seems to be unique here again is that well, maybe I'm misinterpreting, but is the logic really being driven by the smart contract here, and the agent is just acting as the interface, or is there more logic being baked into the agent as well?
Sorry, could you repeat that?
Yeah. So when we talk about like the logic of what the agent's going to do, is that being largely driven by the contract itself, or by the agent, or some kind of both?
So the logic, yeah, that's a great question. Just one sec. Obviously I can't multitask.
It's okay.
Just one sec.
Yeah.
Unfortunately, on this laptop, I didn't have my testnet wallet set up. So
No worries.
and I do have to fund this little guy. So hang on one sec.
Yeah, I'm gonna bring up something while you're doing that. So if people, no worries at all. We can make magic happen live. So if people didn't check out the recent here blog article, I would definitely go check that out on near.org. It really kind of gives an overview of what shade agents are. There's some nice graphics here to kind of explain what Matt is going to show us and walk us through here of how the whole stack works, the T and all that other parts of it are kind of interacting with the agent and everything else from there. There's also, we go down to the bottom, there's links to everything that Matt is showing here as well, like the GitHub template, the actual docs for it as well for shade agents. And then, we're going to talk about how chain signatures and everything else fits into this as well. So you can see all those pieces here, all on the blog.
All right. Yeah, that was a great overview. And that's at near.ai/shade, or there's some short and sweet URL to get there.
I'll find it.
Okay. So I'm back. I got my Near wallet booted up again.
Right.
And if we look at Phala Cloud here, I've got Shady running. So basically, all I did was kind of use the Docker YAML from the Shade Agent template repo, and then we just deployed on Phala, and it was pretty easy. It's very fast too. I wasn't making excuses for Phala. Like, it's lightning quick. Like, they boot up these agents in like less than a minute and stuff.
Yeah.
So I mentioned. So this agent, it's an Next.js app. So it has an API, like it has a backend that's like Node.js kind of backend, and it's, it could talk to services. It could, like, if you give it your LLM credentials for some LLM service, it could talk to that. It can do a lot of stuff. But this is just the template. So we're just going to walk through the core piece of like registering this particular worker agent in the smart contract that we deployed. So I'm going to go ahead and just boot up the page for this, and it says, based agent template, and right away it says fund the worker agent account. So the worker agent has its own ephemeral Near account. And one thing that you can ask me about this again, Joe, when we just get through kind of one run through of this, is that this account, that the T could go offline. So the instance of our worker agent could go offline, and this account could get lost, but that doesn't stop us from basically having other worker agents. And we'll talk about that in just a sec. Okay. But I'm going to go ahead and fund that account right now. I'm just going to shoot it one Near. This is running on testnet, so don't really care. Just fund it with one Near. By the way, you could fund these transactions with meta transactions and stuff too. So like if the T goes offline with that particular account, you wouldn't lose the Near, right?
Right.
There would be no Near in that account. You'd just be funding it with meta transactions. So, there are ways to deal with this. So now that it's funded, we've got our funds in there. And what we want to do is we're going to register the worker agent in the smart contract. So I've already deployed the smart contract that corresponds with the worker agent. And, when you're doing your projects with the Shade Agent template and Shade Agent stack, you're going to modify the smart contract, and you're going to deploy that yourself. So you're going to change this. This is just an environment variable for the contract ID. And then you're going to deploy, obviously, your own worker agents. So we'll talk about, like, you asked that question earlier about like, where's the logic and stuff. We'll talk about the division of like where we think like it's kind of necessary to break down the logic between the worker agent and the smart contract. We can talk about that as well. So I'm going to go ahead and register. This just hits a method in the smart contract. Now this actually passes in the remote attestation, and it actually, the remote attestation is basically like, think of it like a web certificate.
Okay.
It's basically getting verified by the near smart contract. So now our T has been verified in the near smart contract. And we've also passed in the code hash so we can get the worker info. So the checksum, actually, hold on, sorry, that auto closes a little too quick. Somebody should change that. I'm going to go to, I'm going to go to the Attestation Explorer for Fala Cloud. This is a really kind of cool service that they have. And they have these attestations here. It says report, and then there's some hash. So I copied the checksum from my running agent. Now this isn't really crucial to your project or whatever, but you could point people at your attestation on the Fala Cloud Explorer too and say, hey, look, it's verified, right? And it's also the same checksum for the attestation that is now burned into our near contract for our shade agent. So that's why I keep saying, like, there's this tight coupling there between the two. And this code hash, the 67B7 blah 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 blah, this one is the same as the one that was in the Docker YAML. So what do we know now? What do we know after we've registered our shade agent, or like our shade agent worker agent? We know our worker agent is definitely running the code in that Docker image. And we also know, because of the attestation being verified by Fala and by our smart contract, by the way, our smart contract's using the exact same code that Fala uses on that attestation explorer to basically check that it's verified as well. So it's this Rust code, and basically the Rust code's running in our near contract, and it's running on chain. So that's pretty cool. So now what do we know? We know basically from these two pieces of information, we know the code that it's running, and we know that it's actually running in a T. Now what we can do is we can call a protected method. So we're calling is verified by code hash. So there's a code hash in the smart contract that it's expecting, so it's expecting that this worker agent is calling with this particular code hash from this particular near account, and it's expecting that those two things match. So we've stored our worker agent inside our near contract based on their worker agent account. And we've also stored the checksum and the code hash. And here we're actually calling a method that would otherwise throw an exception if we didn't have all of these pieces matched up, if we didn't have this like nice tight coupling between basically code running in a T and smart contract we've deployed. So does this all kind of click? Does this make sense?
Yeah. So I think just to make sure everyone watching understands as well too. So this initial part is basically allowing, it's saying, look, everything here is now verified with each other. So anything going forward here, we've now coupled this agent working with this contract on this T, and now going forward, anything that happens from here, we know is verified.
Yeah, let's take a look at this diagram, which is in sort of, the blog post and the README and the Notion page and stuff. This is on the README on the Shade Agent template, so you guys can take a look at it. But yeah, it's basically what we've been talking about. But just to kind of hammer home the concept one more time, we have got a trusted execution environment. That's this like dark kind of rectangle here on the inside. And we've got this worker agent code that's running inside of it. We derived an account. We got a remote attestation that says that it is in fact running inside a trusted execution environment. And we've got some actions, right? Like maybe we want to call a method in the smart contract or whatever, right? Now this worker agent can talk to external APIs, compute, storage that are outside of the trusted execution environment. But we know that the sort of requests and response that the worker agent's making to those outside services, we can still see them inside the T environment. And so by virtue of kind of verifying that code hash, we still know how the worker agent is going to handle those responses. So like when people talk about, agentic AI, the behaviors, the commands, the responses, everything the worker agent does is still inside the T, even if it does rely on some external sources. It's how the worker agent is going to interpret those resources and eventually sort of act and interact with the smart contract that's important, right? So
let me ask you a quick question here. Maybe I'm just talking out of pocket. Is this almost like having a personal oracle? And the reason I say this is because I'm able to go outside and get external data, right? And yes, maybe the data is not fully verified because it depends on what the data source is, right? But at least for myself, that agent is verifying that it got it from the place I asked it to get it from. We know that it's coming in. It can now talk to my smart contract. It becomes that middleman for whatever my activity might be. Is that a reasonable analogy?
Very good analogy. Yeah, this could be your own personal oracle. So for example, let's say you want to trade, right? And let's say you go to that outside price source. And this price source, let's say this price source is even malicious, but your worker agent, let's say you just put in a piece of code, you said, hey, you know what? I'm not messing around with any wild price swings. I'm not messing around with anything that's too far outside of what I know to be normal, right?
Right.
And so the worker agent could get a price feed from, a bogus source, or we could have one of these major kind of swings or whatever that isn't really, in crypto. Some of those candles are not so accurate, right?
Right.
This worker agent could actually have code that actually kind of buffers and protects the eventual consumers of that in the smart contract. And again, because of chain signatures, out on multiple chains. This worker agent could protect against that. And that could be like your personal kind of price oracle. And that's like, you could choose the way that you would want those prices to be interpreted.
Right. Interesting.
Yeah. So again, like we've got the worker agent code running in the trusted execution environment, and that's really how it talks to, and also by the way, by the same virtue, I mean, what do we know about LLMs? I mean, like sometimes the kind of stuff they're coming back with, not so great, not so factual. So we might not want to make decisions based on that. So that's where we can have our worker agent code kind of be like the buffer before we actually go to the smart contract method to take some actual meaningful crypto action on that. So that's basically like the stack and it's we're really excited because we know we can verify the code in here in the worker agent, and we know we can restrict worker agents to calling only particular smart contract methods as well.
Yeah.
I'm going to scoot down to the bottom to kind of talk. Actually, wait. Sorry, I got one thing to talk about here. So this is kind of an important diagram. And on the left side, we're talking about basically current kind of T implementations. A lot of people are talking about putting agents inside trusted execution environments for sure. And that's a great goal.
Yeah.
What we've seen, though, is that we've seen a lot of people try to handle, this is a little key down here in black. We've seen people try to handle the key management inside the T. So what happens when an agent goes offline and it's managing the keys that talk to the smart contract and stuff?
Right.
Well, we got problems, right?
Yep.
And so you really need a decentralized key management solution. And so with these worker agents, like I remember I funded this account and I basically said, yeah, you could just throw one near at it. You can use meta transactions. It doesn't really matter what this account is, because in our stack, the real key management is handled on the smart contract. So the worker agent, you could think of the worker agent as really it's kind of a stateless, like non-custodial agent. It doesn't really do anything. It just has rules. So you could have deterministic rules for how to deal with prices. Like, hey, I'm not going to accept anything upper or lower than this. You could have stochastic kind of rules that are based on the responses from LLMs. But basically, you just have this stateless rules, and then you have these actions on the smart contract. And the smart contract is really where the keys are managed. And we can manage keys for user deposits. We can manage keys for a protocol. We can manage keys for representing kind of members in a DAO and stuff. So we could have like one particular variant of a worker agent is represented in the smart contract. Like, let's call him worker agent A, or I like to call it worker agent 007,
Right.
Operating on the smart contract. And that worker agent could go offline. Like the dev who's running the T could run out of money. AWS screws them over. Something happens, right?
Right.
Now, as long as they can boot up a new instance of the worker agent with the same code, they can have access to the same smart contract method. So they're still worker agent 007. They're just the new instance, right?
So is this, and maybe I'm jumping ahead, so you can tell me, we'll wait till later, but this is though what enables the chain signatures and chain abstraction, because we're putting the keys in the with the contract versus the actual agent.
Yeah, exactly. Yeah. And here I've got multiple worker agents with code hash _A, and they can all access the smart contract method, all of them, because they're running the particular piece of code, right? And then in a different design, we could think, okay, well, I'm going to have a smart contract, but I'm going to have code hash A and I'm going to have code hash B. And so we can have two different worker agents with different code bases operating on one sort of smart contract protocol, right? So we got this protocol for trading, and it's got a price agent, and it's got a resolver agent for trades. It's got a picker agent, a sequencer agent. It's got all these different agents and stuff, and they can all operate on different parts of the contract. But the real key is, if you're running the code in the worker agent, you can call the method in the smart contract. And that's how we've sort of we created that bond between the two.
Got it. Cool.
Yeah. So we're pretty excited about it. I can dive into like a little bit of the code too, if we want to get like kind of super nerdy here for a sec.
Yeah, I mean, yeah, let's go through that, because I'm seeing the picture here, and I'm seeing what really is starting to differentiate these type of agents from other things that are out there in the market today. So I think it might be good to kind of then let's pull some of the code in here and see.
Yeah, sorry, I just I grabbed the wrong. I went to the public tab and not the pages. So I'm going to duplicate a couple of ones here so that we can just kind of hold them up at the same time.
Yeah.
I'm going to just pull up the contract. Just give me one sec. Okay, so I'm going to pull up two pieces of code here on the worker agent side. So what we're going to look at first is we're going to look at I lost the diagram, but it's okay. We're going to look at the worker agent. So that is the code running inside the T. And this is running basically a Next.js app, but we're just going to look at two of the critical pieces of code here. Okay. And what I mean by critical pieces of code is, with that worker agent, if we look at the UI, actually, we're really only concerned with how do we get the account? Like, how is this account derived? Because obviously we would not want this worker agent's account to be exfiltrated, because if somebody could boot up a worker agent with a particular code hash that allows them to call these protected methods of the smart contract, but the key was leaked, right? And that's another cool aspect of running inside the T, is that exfiltration of data running inside the T, because it's confidential and it's a trusted execution environment, is very difficult. So as long as the code is not leaking out this near account, we can be sure that only instances running the code base can actually call the methods. And then the other one is the code hash. So we'll look at the code hash part in a sec. But first, how do we derive the account? Okay, so when a T is booted up, there's just this is just a tiny bit of code, but just to give people some assurances of like, how are these ephemeral accounts related to the T being booted up, because they do represent the access to those methods on the smart contract. So we create some in-memory randomness. We just use, crypto, subtle crypto, whatever you want to call it, get random values. So we fill an array, 32 values. And then down here in the production environment of a T running on Fala Cloud, we basically get this tap-D client. So this allows us to access some information about the T's hardware. And one of the things we do is we call derive key. So we even feed in randomness to that. And then basically we get a hash of this we take a hash of the in-memory randomness, the one I created up here, which is unique to that instance of the T. And then we also take the T entropy, and basically I concatenate those and I create a hash. And what do we use that hash for? Well, we use that to generate a seed phrase for a near account. And then basically we get an implicit account from the public key, and then we set the key for that implicit account to the secret key. Now, we do have to make sure that the data.secret key in this code base is never exfiltrated. So there is some code to inspect with a worker agent that should actually be kind of inspected, audited, looked at, but you can tell right away it's very, very small amount of code. All we have to do is make sure that when the account's derived, and by the way, set key is just calling, set key on the near key store. And then remember, it's an in-memory key store. So we're in memory, we're in a trusted execution environment. As long as we just generate the secret key and put it straight into the in-memory key store and we don't tamper with it, we're good. Does that make sense?
Yep, makes a lot of sense. Yep.
Cool. So that very little code to inspect. Like, so audits shouldn't be exhaustive, and they don't have to be crazy. You just say, hey, look, this is where I generate the key. Then I put it in the in-memory key store and we're done. And they go, oh, okay, cool. So shade agent template register on the Next.js app. So again, this is under pages. It's just the Next.js kind of typical structure, pages API register. Yep. So how do we register our shade agent? So once again, we go get that tap-D client endpoint. Now this first thing we're going to do is we're going to call client get info. So this is getting info from the T environment, basically from the hardware like that it's running. And what it's pulling out here is it's pulling out that Docker Compose YAML, and it's actually extracting the code hash from it. So again, this is like running. So every time you deploy a worker agent on Fala Cloud, it sits on top of, like, it deploys your Docker image, but there's also this other service running called Fala's D stack. And what we're doing here when we call client get info is we're pulling the code hash out of that D stack. And that D stack, Fala, these guys know what they're doing. That's all good. That's audited. That's pretty hardened, right? So we're pulling a piece of the Docker Compose YAML that has our code hash out of that D stack and into our app, because we're eventually going to register in the smart contract. So now what we do is we get the attestation quote. So this is a TDX quote. So again, you don't need to know the ins and outs of these quotes and stuff, but they're basically, think of them like web certificates, begin certificate, end certificate. There's a bunch of data about the certificate. And then what it does is it actually makes an end run through these Intel, these special URLs called like PCCS URLs, makes an end run through there, goes and gets a bunch of extra information about that. We're using an endpoint here for convenience that Fala exposed. It gets all this information about the certificate and also like the kind of like the root, like kind of web of trust for the certificate. And then finally, once we have these 4 arguments, and again, the last two are just the ones that we want to store in our contract. The first 2 arguments are really important. It's the quote itself. And then this collateral is sort of the extra information from that URL I was talking about that quote, that attestation quote. So that these 2 are what our contract needs to actually verify the quote. And then once it's verified in the contract, we're going to store these 2 pieces of information.
Got it. Okay.
I know it's a lot. You don't really need to, like, if you just want to like launch an agent and have some fun, you don't need to know all this.
Right. No, yeah. No, but it makes sense to talk it through a little bit here so people
just
get
get
what's going on.
For sure, for sure. So I wrote in the contract, I just wrote, register args are here, like, and this is what we just looked at, right?
Yep.
So, I mean, I got to update that URL. We've kind of moved it around a little bit, but register worker is what we call on the contract. And basically what I said is we're going to pass in the quote and then this collateral from the URL. And basically, we just have to kind of parse a few things. And we also have to get the current time because we want to verify that the attestation quote is up to date and everything. And then we call this verify method. Now, this is coming from a crate that Fala put out. It's called decap qval. You don't really need to know what goes on inside the crate, but like I told you, it's basically taking the quote is like a certificate, and then it's taking the certificate and this extra collateral about like where the certificate came from and stuff, and like what is the root web of trust, and it's basically just verifying it. So it's checking the web of trust and all the cryptography around that quote, and it's basically coming up with, is this verified? And so it's going to spit back, true or false. And then what the contract, the worker agent contract does is it says, okay, if the result is okay, and there's some result there. And by the way, it gives back like a report with some information about the attestation as well. And if you're really kind of nerdy and you're into this T stuff, that verified report will have a lot of extra data in there that you can dig into if you want to. But here we're just checking that the existence of a verified, attestation report is coming back from our call to verify. And then what we're going to do is we're going to store, typical near fashion. We store the account ID of the caller of this method, the predecessor, and we insert worker by account ID. We insert predecessor, and then we insert worker with those last two arguments I was talking about, the checksum. So we can verify the attestation on the Fala Explorer if we want to, like later, or show it to our users or whatever we want to do just to be, verified.
Right.
And also we store the code hash. And why we store the code hash is obviously so we can do some interesting things, like we can protect methods and make sure that they're protected by approved code hashes. So I've got a method here just as an example where it's verified by approved code hash. And here, to approve a code hash, you'd have to be the owner of the contract. Now, we're not going to, we can go down the design routes of like, should the owner of the contract be able to arbitrarily throw up new code hashes to be approved?
That's what I was going to ask. Like, can you have multiple things like that? But really, we're focused on just the one.
Yeah,
right
we're
now.
focused on just like the template. This is a basic example of sort of showing that it is possible to basically safeguard a method by a registered worker agent with an approved code hash. And this pattern of like allowing the contract owner to just approve arbitrary code hashes, obviously not the best pattern. So in practice, you would probably release your contract with with an approved code hash, but then you would have to add in some upgrade logic that would allow, like it would allow the developers of the protocol maybe to push a new code hash. But for instance, there could be like a cooldown period where like if users have funds deposited in the protocol,
Sure,
they could basically there could be a cooldown period of like a week or something where the devs are like, okay, we're rolling out a new worker agent, and here's the code hash. We're going to give it access to the same methods that the previous agent had. If you guys are cool with it, you've got 7 days to decide. And then all the users can come to the contract and withdraw if they don't like it, or they can just leave their funds in, right? So we leave this up to the developer as to like what they're going to do with this pattern and all of this cool kind of stuff and how they can
Sure.
upgrade agents and stuff. I'll just kind of scroll down again to these diagrams, like they're way at the bottom. So we basically facilitated this where worker agents can call protected methods in the smart contract, or you can have multiple agents calling different methods. We created a template that facilitates this, but we don't really prescribe to you how you should use this in the contract. And I just threw in a whole kitchen sink of like helper methods just to get your mind going about all the different possibilities. But make no mistake, Joe, like this is big. Like this is big. We've got these worker agents, running inside these trusted execution environments, and now we can definitely verifiably know that they are only able to talk to these methods in the smart contract. And not only that, the smart contract, like the worker agents running inside the T, the agents are not the custody of the funds. It's the protocols are now we're back on chain. We're back on chain, decentralized key management. We're on any chain with chain signatures, so we're in a good spot, but we still get to run arbitrary code and call those methods with agents.
And by having the funds on the protocol side, that also prevents let's say for whatever reason the LLM hallucinates and calls the wrong contract. Okay, for whatever reason. Now you're not so concerned about that because the logic that's in there and the contract, whatever else, and the funds are now still tied into the agent being connected to that particular contract. Or can it go kind of rogue?
Sorry, repeat that again.
Sure. So if I, by the funds being in the protocol at the protocol level instead of it being directly tied to the agent, that if for some reason the LLM hallucinates and now calls the wrong contract, it's trying to do something, my funds though are still protected because the connection is between that agent and that particular contract. And so even if it makes a mistake, it's not going to just start sending out funds.
Exactly. Yeah. So you can have the best. Well, what do we know about code, right? In runtime, in practice, right? You can have the best code in the world. You can have all these checks for all these edge cases, and I think back to the days when I was a kid and I ran like a PC. You could still get the blue screen of death.
100%, right?
And so these worker agents, like I said, they could be talking to LLMs that could be hallucinating. They could be getting bad price feeds from off chain. Doesn't even matter if the LLM is running inside a trusted execution environment. That doesn't give you any guarantees. So I guess the big question is down here. We had this diagram, this one with the current T implementations. Why would you give an agent a key, right? So what we're doing instead is we're giving a worker agent just an ephemeral access as an instance of that code to talk to the smart contract where the real key management's done. So you can build in all these protection balances against LLMs hallucinating this and that, and blah, 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 blah. And then you can build in the final kind of hard and fast rules around custody of assets and key management in your smart contract. So instead of otherwise, can you see my cursor?
I can. Yep.
Yeah. Otherwise, if we didn't have the smart contract sort of in play here, or if it was kind of a very naive kind of pass-through contract that just let the worker agent do whatever, we would really be drawing an arrow directly from here to these assets, and that wouldn't be very good, right?
Right.
Even if we thought we had the best agentic code framework on the planet.
Right. You still always run that risk. Yeah, sure.
Yeah.
Yep. Makes sense.
Cool. Yeah. So one more thing just to go through. I forgot we had another diagram here in the README. And just this kind of just shows the delineation between the worker agent and the smart contract and what a typical registration flow would be like, and then kind of where the loops are once the agent's registered. Because some people might be thinking hey, you mentioned you're verifying web certificates in the smart contract on chain. Isn't that expensive? Yeah, it's a little pricey to just register, but on near a little pricey is 3 cents.
Right.
So to register, sure, it does cost a certain amount, but then every transaction after that is really just doing that require, check the code hash, get the worker. That's cheap. That's super cheap, right? So let's go through the deployment of the worker agent. So you deploy, check if the account, and this is what I did in the very beginning. Deploy, check if the account's funded. No, fund account. Is it registered? No. Okay, call register, get the remote attestation, get the code hash, pop it in. Then the smart contract takes over. Is the attestation verified? No. Okay, we're going to throw an error. So the worker agent can't get registered if the attestation is basically crap, right? But if the attestation is verified, then, yes, registered, yes, attestation verified, we can start making transactions in the contract. So transaction, approved code hash. Am I allowed to do this transaction? Am I allowed to call this method?
Yeah.
Yes, return output. No, throw error, right?
Yep.
So this is the flow. And then eventually, once our worker agent is booted and registered the first time, we're really just doing, we're just doing like this all day long, like transaction, right? And then check approved code hash, yes, return output. So we're really just doing these three from our worker agent. We're calling transaction and we're just ripping straight through if we're approved to output. So yeah, we think that we think the stack's pretty cool, and we think that we've kind of thought of we've thought of a lot of the the current, a lot of the current kind of I guess pain points in the space is I want to launch an agent and I want to have a token for the agent, but I really want the token. I want people who want to be part of this ecosystem. I want them to understand that the agent is the token, and it's not a token that some dev launched that sort of represents some agent in a cloud. Maybe it's in a T, maybe it's not even in a T, that's just chatting on some Twitter account, or doing some sort of mind share tweeting, or sort of crypto insights or whatever, hey, check this out. So I think that people are kind of the meme space in the AI agents is kind of fallen apart a little bit, and I think, and especially meme tokens are kind of taking a dive lately. I think people are hungry for quality. They're hungry for quality agents and quality products. Yep. What we think this is going to replace is, we think this is going to probably replace a lot of human intermediaries. Kendall spoke about this yesterday on the live stream. We think that shade agents, they have that non-custodial verifiability, they have a lot of things built into the stack. And what we think they could replace is they could replace a lot of human actors that are currently in spots in DeFi. So for example, there's price oracles and there's lots of things happening, and it's a lot of kind of there's still a few humans in the process and stuff, and we could probably replace them with agents or instances of worker agents that are basically shade agents, because they're verified by the contract as well. We could create a lot of fun kind of app chain style stuff. So a lot of people are booting up, they're making a game and they're booting up an app chain. It's an L2, and they're committing to the L1 and they're doing all this stuff. But really, I mean, the whole game logic could be running in an instance of a worker agent, and then periodically just burning its state to the smart contract, right? Because these worker agents can talk to, they can talk to the wider web. They can do all sorts of stuff. I mean, they could do WebSockets. They could do anything. So you could do a lot of fun use cases in that.
Listen, I was going to ask about that, because of the way it's structured, and it is sitting on the regular, we'll call it Web 2, whatever. You can really treat it like its own API system. So I could send any kind of data, like you said, I could use WebSockets, whatever I want that to be for me on top. So the agent doesn't have to be the product; it can be part of the product that I'm building as well.
For sure. Yeah. And I mean, there's so much you could do. You don't even have to build an agent, right? We're talking about agents lately and agentic AI, and especially, having agents kind of manage crypto assets or manage processes in DeFi. Like I said, price things and resolving trades and things like that. Having agents manage that is sort of a big theme and trend coming up. And I do think that a lot of infrastructure will sort of be kind of replaced with good agent code that otherwise would have had to kind of rely on kind of humans in the process and stuff. I mean, you could actually think of here's a great example. Sometimes in a web predictions market, people basically betting on the outcome of something, there's a conflict, right? So what was the actual outcome? And then there's these protocols with these very complicated, conflict, dispute resolution. You got to get 12 people from over here and 17 people from over here, and like everybody's got to vote in and do all this stuff. That's complicated, right? Now we could play, we could play a lower stakes game of this and just basically, as long as the 2, 3, or basically the X parties on the one side of the prediction and the Y parties on the other side of the prediction, as long as they're all basically willing to trust this worker agent code hash, like I said, they can go look at the code if they want, and the LLM that is going to resolve their prediction, then that's it. That's the end of the game. And basically the worker agent will sort of rein in on the smart contract, and the funds will be distributed. Right?
Nice. Yep.
Does that kind of make sense?
It does. It does. So I mean, and it feels like I could, ideas that come to mind of like if I wanted to make my own like personalized mini decks, like there's certain actions I always want to do, that could build that out. The human I'm replacing maybe is myself, right? Like, let's say I know that every couple of weeks I do a consultation work and I get paid a certain way, and now I want that to be transferred to my base account, whatever it might be, right? I could start to build in my own agent that is processing all that for me. I'm no longer going through those manual steps. It's just doing that accounting for me.
You could package up that shade agent too, and you could sell it to somebody else. And you could say, hey, listen, like, do you want your own instance of this kind of personal DEX shade agent?
Yeah. Interesting. Now, one thing I meant to ask earlier is, so the data going in to this, because it's in the trust execution environment, even though I can verify the code, maybe I don't see data in and data out. Is that correct? Because that's staying within the environment.
Yeah, if you're looking for more like data in, data out, provenance, things like that, probably look to some of the other projects that Near AI are doing, like Asimov protocol and things like that. They're working on solving that problem. The shade agent stack doesn't inherently solve sort of like, a garbage in, garbage out problem.
Right.
But you can write code that could maybe recycle garbage.
Right. or what if I wanted to put like personal information? Like, what if I built an agent that was about like my health? And so I don't want to expose that. Is this environment and this structure able to handle like private information like that?
Yes. So actually, trusted execution environments and like ones like Fala Cloud and stuff, they are confidential as well. So like I mentioned, the worker agent is handling basically in its memory a secret key to talk to the contract, right, and represent its sort of claim that it's running this particular code hash. So again, like that ephemeral Near account is tied to that code base and it talks to the contract. But how do you know that memory is not getting out, or that data is not getting out of the worker agent? Well, they do run confidentially. So I'm not sure so much about like private storage options or something like that. But if you wanted to have that worker agent like loading data that was encrypted, for example, from an encrypted data store, I mean, you could have the worker agent encrypt everything in memory, and then when you send it out to storage, it can actually be stored fully encrypted. Then and when you need it, the worker agent can pull that in, decrypt it with its key that's in memory, and basically go from there.
Yeah, it's interesting. And I guess my larger point was trying to get at too, for like people who are looking to build here, is that like you are not bound by just the concept of tokens and DeFi. So it is much like people can really start to experiment. This architecture, what I find interesting is that it's solving a lot of problems that I have been seeing right now in current AI architecture. But it doesn't have to just, the DeFi is the easy example, and tokens are easy example. But it doesn't have to be that. It could be whatever you think that you want to build out.
Yeah, we've got a couple of experiments that are kind of going to launch next week for East Denver, just for fun and stuff. So, for example, we've got a worker agent that is going to be connected to a Twitter account, and then when you talk to it, and if you provide provide positive sentiment about shade agents, you'll get rewarded with tokens. And if you provide negative sentiment about shade agents, you'll get rewarded with a different token. And what we're doing here is we're really just hammering home that concept that the worker agent is the only one that can mint those tokens. And it's a toy example, right?
Right.
But what do we know from these toy examples is that they can turn into something a lot bigger.
Sure.
And like I mentioned before, within the case of app chains and the case of like sort of games and stuff, like a lot of games are sort of running as their own app chains and stuff. And I personally think that might be wholly unnecessary with this kind of stack, because I mean, a game really just needs, some sort of brain about the game state and the logic and how to sort of resolve what the next moves are and stuff.
Right.
You can do a lot more. You can do a lot more with the code base inside a trusted execution environment than you could, say, running on an app chain or basically running with some sort of zero knowledge kind of architecture, right? This is just regular, code. It's just whatever you want to write it in JavaScript. We've got another agent for next week that's written in Python. So we're going to add a Python worker agent to the shade agent stack as a template. So we got another agent coming that's written in Python. That agent basically talks to Kaido, and it finds out who's got mind share, and then it basically it's going to trade assets based on mind share. And we're just gonna we're not gonna open that up to the public and say, hey, you can deposit and this mind share agent will trade for you. We're just going to launch the agent with the shade agent stack, and we're going to put in our own funds just as an example, and we're just going to kind of chart how the agent's doing over time.
Right. Interesting. Before we wrap up, I do have one question
sorry, I fully shamelessly, I should say, we've got the AI hackathon going on. I'm sure you know all the details. We've got East Denver coming up. I'm sure you got all the details, so please show those. But my big call to builders is just to understand that this is really, really kind of like it. I can't say really, really, and then kind of, right? This is really a big deal.
Yeah.
So it's such a big deal that we just feel so strongly about it that basically quality agents that can actually manage crypto assets and do things and have users deposit into Chain Signatures accounts from all different chains and stuff. And then the worker agents are verified and everything. This is huge. Like, this is a big kind of step forward in these frameworks and architectures and stuff. And again, like, I work at Proximity and we do a lot of this research and development. We're just giving this away for free. We want people to build with this stack because we think that it is actually, like, we believe in true non-custodial DeFi. We think this is the way forward. So we think it should appeal to a lot of serious developers and even some of the project teams that you've sort of seen or heard about that are building AI frameworks. I mean, they're kind of interested in this, and we think other builders should be too.
Yeah, for sure. I mean, I've been talking to a lot of different AI groups, not just on the show, but just outside of it as well. And I will say this is not just shilling. This architecture is impressive, and it makes so much more sense for building out things again that are supposed to be either both, controlling funds or any kind of private information, things like that. I do want to catch you with one question from the audience before we go.
Sure.
The question was, can it support long-running processes, for example, like scraping, or is it kind of single transaction based?
Yeah, actually, so I'm working on that Twitter agent that I mentioned before, and that Twitter agent, it doesn't use the Twitter APIs. It uses the Eliza OS agent Twitter client, which is basically based on a Twitter scraper. So
awesome.
What I feed into it is I just feed into it credentials like of just some arbitrary Twitter account, and it basically, like, it handles all the login, the auth, all that stuff, and then it just goes and it starts running searches and scraping. So the worker agent is basically, I think the question was sort of around resources and stuff.
Yeah.
And we look at Phala Cloud. And by the way, we currently can deploy in Phala Cloud. We love these guys. They're great. We think they're the best, like, in the T space so far. I sound like Trump, the best. No politics. I'm Canadian. We think that Fallow Cloud are doing great work in this space, but there are other offerings out there, and we are going to explore adding those. Just like we're adding a Python template to make a Python worker agent, because a lot of people are coding in Python and especially talking to LLMs in Python.
Yeah.
We think that it's important to maybe have, we're going to definitely have the Shade Agent template and sort of a Shade Agent stack for working with Near AI, which will be launching soon as well. But there's also other providers out there for Teas. But let's look at the resources here just for fun. Oh, it's under advanced, I think. Yeah, compute resources. So, there's no available nodes right now. Whoops. Okay, so they ran out of resources at the moment, but should be back soon. But basically, I've seen lots of hardware options out there. So can it handle scraping? Absolutely. I think I'll stop my screen now.
Yeah.
So can it handle scraping? Absolutely. It's as big as you want to imagine it. And also, by the way, this is another interesting thing. Like Fallow might not be running GPUs and your LLM might be hosted somewhere else, but it doesn't mean that you can't host your LLM somewhere else and have Fallow the Fallow worker agent talking to it, right?
Right.
Now, again, like it's up to you as a developer how you want to kind of sell this narrative and stuff about what the worker agent code that is verified and sort of tightly coupled with the smart contract and that verifiability. It's up to you what the worker agent code does. Does it talk to external resources? Are they good? Are they crap? Whatever. That's up to you as a developer to decide and build.
Nice. This was a great presentation. I certainly learned a ton. I am certainly impressed with the work you guys are doing over there at Proximity. And I'm really looking forward to seeing
why we called it Shade Agents.
Why is it called Shade Agents? Okay, great point. I should have asked that.
Well, we tried to call it something else. We'll talk about it. You can figure it out for yourself. But we ran into some sort of, just some just naming conflicts. It wasn't really, nobody was really upset or anything, but we just decided to shift to Shade Agents. Nobody's really using that nomenclature. Why Shade Agents though? Because when you're running inside a T, it is confidential. And you could think of like your worker agent and the Shade Agent stack is kind of like, the trench coat's pulled up, the sunglasses are on, I got the fedora, I'm sleuthing around. I'm working in the shadows. I'm getting you the good data. I'm getting you the good inference, the right stuff, the right agentic code.
I like it.
And I'm doing actions in the smart contract. So this is your agent. They can be confidential and everything, and they're working on behalf of you. I loved your example, by the way, Joe, of the personal DEX and trade agent. It's something that I think is definitely going to be a big narrative.
Awesome. Yeah, no, very cool. This is really cool. I could see a ton of uses for it. I hope people check it out, and certainly excited to see you guys do it at Denver as well. So great stuff.
Yeah, we'll have lots more sort of like little announcements and kind of posts coming out. So yeah, follow at Proximity Fi, and obviously at Near Protocol, who will be kind of like retweeting and quoting and shilling our Shade Agent stuff. Yeah, we've got a lot of fun coming up, and we're looking for more builders. So definitely reach out, get in touch.
Awesome. Well, thank you so much for your time today. I really appreciate it. This was great.
Yeah, I really appreciate it, Joe. Thanks.
All right, thanks, Matt. Yeah, folks, that was awesome. Really definitely check it out. All the links are below to get started yourself. We also have, as Matt alluded to, there is a bunch of different hackathons going on right now. But right now, the 1 trillion agent hackathon is still going on. The deadline is March 2nd for you to get in there. And tons of stuff to still be built. There is almost 1,800 participants in that one. It's fully online. Let me bring up that link below for you guys to see that as well. So that will come scrolling across here. Make sure you're subscribed to the DevHub newsletter, because we will also have all those updates. So when Proximity releases some cool new examples or whatever else that might be, or updates to this stack, we will have that in our newsletter. So make sure you're following along there as well. We will have all kinds of stuff next week as ETH Denver is going on. We will have a few different live shows. We'll pretty much be live almost every day at some point next week. So keep following along here. If you have questions, if you want to join into the conversation, join the dev support channel. We can link you to the right spot. Make sure we get you in touch with the right people and kind of go from there. So until next week, enjoy your weekend, folks, and keep building. And until next time, I'm Joe, and we'll see you then.